Hello, everyone. Welcome back to Advent of Code 2022. I'm actually, when is this video going up? Is this going up in? Yeah, it must still be March. Um, I'm teaching myself Kotlin by solving Advent of Code problems this year. Just doing it in March instead of December. So yesterday we did day 8, and I think, the most cleanup I've had in between episodes of things I thought could be cleaner. You can see I made 3 different changes to improve things. So I wanted to review these before we get started. The first is, I observed that it's just kind of... Oh, I guess I made a... Can I... What is this diffing against? Is this... The left side is before and the right side is after? Okay. So I guess I also got rid of some with clauses here that I thought were not really very helpful. But the main thing this commit was supposed to be doing, I thought, was this looking up of, getting the y and x components of a coordinate, and then looking in the forest's trees for that y and that x. That's a little error prone, right? We don't want to be working with y's and x's. We're working at the level of a single coordinate through most of this program. And so I wanted to just be able to index the forest by a coordinate. And to that end, I gave the forest class a get function, which is the operator for, index access like you saw before. And it just says, you give me a coordinate, I'll look in the trees for that y and x. And so then this whole question of whether we're row major or column major doesn't matter anymore for the rest of the program. It's just look stuff up by coordinate. And some of that cleaned up, like, I think somewhere I probably wrote with forest and I got rid of that or something. I don't know. But mostly it's just simpler, like, oh yeah, right, here, for example, I had to write this whole lookup function that was like, look in the forest for coord y, coord x based on the coordinate that I have. But once forest can be indexed just by a coordinate, it's way simpler to just, like, why call lookup of start when you could just call forest of start? Why define lookup, right? So that was I think that was an improvement. Then I said, there's a bunch of these with clauses that I never really liked. Some of them are still nice. I left some in. But some seem sort of gratuitous, where here I said, oh, gosh, let's just have x and y implicitly in scope. And then I can say x is x times whatever. But, like, really, wouldn't it just be nicer and more clear to say this x comes from the start position of the plan, this y comes from the start position of the plan? And it looks like there's another down here where, like, yeah, I said with forest from height to width. But, like, just say forest.height and forest.width. Seems clearer. And lastly, the one that I think I'm happiest with, I did just a minute ago. I got rid of all of the places where I could have an off by 1 error, I think. By stages. I made it, I refactoring, and I was like, oh, I can make this a little better. And then I refactored a little better, and the IDE was like, actually, you could make this better too. So I didn't know that lists, or this list, yeah, have this indices mix in, or extension function, I guess. Oh no, this isn't for lists. Wait, what? Oh yeah. Every collection has an indices function that returns a range. So I first refactored this to say, okay, a tree should know its bounds, and it should be 0 until trees.size, right? And then I went through and fixed all of the places using it to use that new idea. Actually, even before that, I replaced height with, like, x max, or y max, which was, like, the height minus 1, because everywhere I was using it, I was subtracting 1 from it. And then I said, oh, I could use a range. I could just store the range here instead of storing the max and having everyone else compute ranges from 0 to max. And then Kotlin was like, well, instead of using 0 ... size minus 1, why don't you use 0 until size? I was like, yeah, that seems better. Sorry, I said Kotlin said that. I think it said that. What really, of course, it was IntelliJ making the suggestion. And then it said, well, if you're using 0 to trees.size, 0 until trees.size, why don't you just use trees.index, trees.indices? I was like, oh, I didn't know that existed. Thanks, IntelliJ. So now the forest, instead of storing its width and height, just stores the bounds. Here's, from 0 to whatever is the dimensions of the forest where you can find actual trees. And so now all the use cases, or the use sites, get simpler, right? We don't have to decide on bounds ourselves, 0 to width, 0 to height. And remember, this is an off by 1 issue. We have to remember to use until instead of ... here. Now we don't, because we can just say, look at the forest's x bounds and the forest's y bounds. Likewise here, I'm saying, multiply by forest.width minus 1. Nope, just multiply by the last of the forest's x bounds. Great. And then one more down here, I think. I have this range, 0 until forest.height. Well, why don't we just use the forest's existing bounds? Great. And likewise for its x bounds. So I was about to say that this, obviously this is better, but I was about to say that now we're completely agnostic throughout the whole program to, what coordinate system the forest even uses, right? Everything is just dealing with coordinates. And, we multiply by its, where do we multiply? Somewhere here. Yeah, we multiply by its x bounds. And so, even if we use a translated coordinate system for forests, it would be fine. We're not just ambivalent to the size, which, it doesn't have to be square. It doesn't have to be size 100. We don't even care about the origin. But that's not quite true, because I do have stuff that starts at 0. So if I were to actually have the forest be somewhere in the middle of space instead of right at the origin, I would have to rewrite. I think mostly scan order, and I don't know, but why would you ever do that? So there you go. That's my refactorings for today. And unlike some previous days, I haven't done the pre-work of making a day 9 input and day 9 Kotlin file, so I guess we'll do that on camera after we read day 9. Rope bridge. This rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. We didn't hear about this rope bridge before, right? It's weird that it says this rope bridge. We're just I don't know. The narration has skipped it up to this point. It seems to support the elves just fine, though. The bridge spans a gorge which is carved out by the massive river far below you. You step carefully. As you do, the ropes stretch and twist. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. If the head moves far enough away from the tail is pulled toward the head. Yes? Due to nebulous reasoning involving plank lengths, you should be able to... I like that. You should be able to model the positions of the knots on a 2-dimensional grid. Following a hypothetical series of motions for the head, you can determine how the tail will move. I see. Due to the aforementioned plank length, the rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent, and even overlapping. Both count as touching. Okay. If the head is ever 2 steps directly up, down, left, or right, the tail must also move 1 step in that direction so it remains close enough. Sure. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail moves diagonally to keep up. Sure. So we moved up from here, and the tail, this and this, are in some sense equally close to the head. But the rules say, it always moves diagonally in order to catch up. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and tail both start at the same position, overlapping. Okay. So right for, yeah, okay. After you step, you need to update the position of the tail if the step means the head is no longer adjacent. Yes. What is S exactly? Oh, the starting position. Okay. So we go like that, and we go up. Okay, fine. After simulating, you can count up all the positions the tail visited at least once. Okay. Well, that obviously screams sets, but what if, just in case, we kept a multi-set? In case they ask us about, oh, how many positions did the tail visit at least 5 times? Then we'll be able to easily check that without having to make any changes to our algorithm. Okay. Sure. Let's get my puzzle input here. And put that in day9 dot, what? No, do not delete directory. New file day9. Cool. And yep, sure, put it in git. New package day9, new file day9. Cool. Yes, put that in git too. So, I think now is the time to start a little bit of refactoring, because when we look at this, there's some stuff that we could reuse, right? If nothing else, coordinate and direction look pretty good. Out of curiosity, are you allowed to say, like, up is north? I assume not, right? That doesn't make any sense. Okay, just checking. Right? I mean, I don't know how much use we're going to have for all of this stuff, but at least, like, you know, adding a direction seems good. We might need to be able to subtract 2 directions to get... subtract 2 coordinates to get another coordinate. But that seems fine. Right? Because we can just, like, if you subtract the tail from the head, then you should get the vector from the tail to the head, right? And if you take that vector and clamp each of its... what's the word I'm thinking of? Dimensions? Its components to a maximum absolute value of 1, then you get how much the rope should move, or the tail should move, right? Which might be 0 if it's... no, of course. That's not right. Because if the head is adjacent, of course the vector will be, 1, 0 or something like that. And clamping it would tell you should move to catch up with the head, but of course you're not supposed to move unless you're at least 2 away. But we can say if the delta has any 2's in it, then clamp all of the 2's to 1's, keep the 1's that were already there as 1's, and then move by that much, right? So that seems nice. And I think, you know, in my previous Haskell Advent of Code puzzles, I didn't really mess with creating much of a shared library. There were 1 or 2 days where there was stuff to share that was complicated enough I didn't want to rewrite it. And I just copy-pasted it. Because I was making them all separate stack projects, and I don't even really know how to manage projects in Haskell and create new libraries and stuff, I didn't do that. But here, it's like the JVM, and also I made it all one project, so it should be no problem. So let's refactor this. Move? Oh, you're asking how much I want to move? That's great. Move the direction 2, I think. But none of the rest of this. To the lib package. And 22, not 23. Why would you say 22? 23, rather? There's nothing in 22 there. Okay, I don't know why you thought that. And let's call this one coordinates, right? There you go. Yeah, put that in kit 2, please. And let's just confirm real quick that this hasn't changed anything here. Do we still get the right answer? Of course we do. IntelliJ would never betray me like that. And we'll just commit that much real quick here. Don't commit any of the day 9 stuff. Just this. Extract coordinates and directions to a library. Let's say to lib. We've called that package the lib package. Cool. So now I don't think we need to look at day 8 anymore. We've pulled out the parts from it that were useful. Or 7, or what is even input? Oh, that's the Kotlin file for reading input, right? Oh, somehow I accidentally closed the... Oh, maybe I never opened the coordinate file. There we go. So, there's a little bit more that we want to do here. We want a few more functions. Operator fun minus takes a other coordinate. Oh, we also don't have to specify this, I guess. Whatever, I'll leave it in. Is with... no, I can't with the other because it would overload my scope here. I would have 2 things named x in scope. But it's just a coordinate of x equals x minus other dot x, y equals y minus other dot y. So very simple. Oh, minux? Yeah, that's not an operator, I agree. And so I think this is a general enough function to put in coordinates in general, right? No one's going to look at this and say, this shouldn't be in coordinate. There's some other functions we could add to coordinate. For example, we could say, you know, what is the max magnitude of a coordinate, right? And then we could say, like, okay, take the absolute value of x, the absolute value of y, and max them, and that would return you either 0, 1, or 2 in our program. But that doesn't really seem like something innate to coordinates, right? So we don't really want to put it in this class, and we don't have to, because in Kotlin, if we want, inside of only day 9, we can say, all right, let's pretend coordinate has this function by writing an extension function for coordinates that will be visible only inside of day 9. And so the rest of the universe can get a nice clean coordinate class. Likewise, clamping to at most some value, some absolute value, seems crazy, right? Why would that be part of coordinate? It makes sense for day 9's problem, but it doesn't make sense in general, right? For coordinates. So we can say fun coordinate dot max magnitude returns an int. Oh yes, let's import it. And we can just say, like, I mean, honestly, I guess we probably aren't even going to need the brace here, right? Which means we can get rid of the int. Is max of abs, I assume? Yes, x abs y. Like, that should be it. I have to import this? What the hell? I said max. Yeah, that one. That one. Okay. And then we can also say, you know, clamp to, you know, something like that. I don't know. Fun coordinate dot clamp magnitudes to limit int. And this returns unit, so... Or no, it's going to return a coordinate, right? Yeah, because we're not modifying the coordinate, obviously. What is actually a good way to do that? Oh, well... Can we just take the signum of x and y? Right? I assume that exists. Sine. What the heck is sine for int? What do you mean sine for int? Oh, int.sine. I see. It's a property. So this is, I guess, just... Actually, I'm not going to need much, huh? I can equals this as well. Equals... coordinate of x dot sine y dot sine, right? I think that's it. Oh, I see. The issue is that I tried to be generic and take a limit parameter, and that gets a little bit... Well, I could just multiply by limit, right? Sure. So in this way, I'm sort of flexible. I would not be at all surprised if part 2 was like, actually, the rope is 5 units long. And as long as it's... If the head is 5 or more units away in at least one direction, then you move diagonally to catch up as close as you can, right? And here we're already ready to handle that, I think. We take the sine, which is either 0, 1, or minus 1, and then we multiply by the limit. So if there was no difference in that direction, we'll still have 0. And if there was a difference, we'll multiply it by... Yeah, that makes sense. So I think these are great functions for coordinate to have, specifically for day 9's problem. which is why we're defining them in day 9 instead of in coordinate. Don't need that though, do I? Oh, I do. Okay, so they're extension functions on int that are not like in the language. They're in Kotlin.math, and you have to ask for them if you want them. All right, fair enough. I think I like that better than putting them directly on int. I just wasn't aware that was how it was done. So, what other types do we need? I mean, we kind of need a rope that has a head and a tail. That seems like an important domain concept. But on the other hand, we could just maintain, you know, 2 different variables. No. We should we should define a class rope which has a val head, which is a coordinate, and a val tail, which is a coordinate, right? Head val? Cal head val? What happened? I don't know if I typed wrong or some autocomplete tricked me. And this probably wants some, you know, move head by function or something like that, right? But maybe not, because that would kind of have to return 2 things, and like, yes, Kotlin has pairs, so we could return like the new rope and this says Tali? Wait a minute, how come you're not giving me grief about the spelling of Tali? All the time you're like, oh, there's typos and stuff. This is the one time I actually had a typo, and apparently Tali is something real in some other language, I guess. Ugh. So we could return both the new rope and also whether the tail has moved or something like that, right? Which, or we could mutate the rope if we didn't use a data class and return like whether, you know, the new tail position or something like that. But I think I'll probably just not do that. And when I manipulate a rope, I'll check its tail afterwards or something like that. Or I'll by hand decide whether it needs to move, or I don't know. We'll figure something out. So, one kind of annoying thing is we need to parse, well, I guess we need like a vector, right? Tell me vector isn't already something in scope. Thank you. Val. So this is it's not quite a vector because I want it to be a one-dimensional quantity that can only go like orthogonally north or east or south or west, right? I'm not sure quite what to call that. Let's call it a motion. It's a val direction, which is a direction, yes, and a val magnitude, which is an int. So this is what we will be parsing our input rows into, motions. So, I mean, let's write a function that parses a string into a motion, shall we? Fun parse takes a line and which is a string and returns a motion. Let's also const val. No, can't make it a const. Val. I'm using a regex again, I guess. You don't have any other tools in like every language except Haskell. Haha. For parsing. val motion, I guess. I don't know. Is a regex of lord and a space and then some number of digits. Gotta triple quote this stuff so you don't have to escape the D. So I think that's fine. We should just be able to say return, and maybe I'll make this into a one-line thing. I don't know. Return action dot motion. Why I read that as action. Dot match entire of line. Let well, let's give it a name. Match. And then we can say val dir mag is match destructured, and we can just produce a motion of when dir right east left west. Oh, let's do it in Lerd order. I just like being able to pronounce it. Oh, you don't want commas? Sure. North. No, not nothing. North. No, I don't think I'm going to need my no route to host exception. Hello? Why are the others so easy to find and north is no good? Direction.north, please. And down to south. And also the mag.toInt. So you're complaining that it could be null? Yes. I guess instead of bad input, I could say no parse line. Oh, that's a good point. This could throw an exception. Yeah, okay, fair enough. Invalid direction dir. Right? So now we've got parse. And I think we could just say make me a REPL and check that parsing works out okay. Yes, please build. And if we look here, yeah, it should be one of the lerds and some number of digits. So I think I believe in what I wrote. And let's parse. Yeah, the one from this file, please. 10R. That's going to be incorrect because it should be R10. Good, you got me. I'm supposed to Control Enter, not Shift Enter. Okay. Although I guess either works. So this parse does an east of 10. Fantastic. That's all we could ask for. Why do I have 3 REPLs? Get out of here. I had like 7 REPLs from previous days, I guess. Okay, so parsing, no big deal. And guess we can just write main now. Val, what do you call a sequence of motions? A path? Is read input of 9.map parse it. Let's make it a variable. Wait, I already did that. Let's give it a type. Do I have to go over here? Yes, the type, please. And I think that's really all main should do. We should just print on of part 1 is part 1 of path, right? And of course, we need the part 1 function. List of motions, that should be an int, I assume? What are we being asked to return? The number of things it visited, right? Yes, correct. Okay. So I think we want, oh, it feels so bad to use a non-immutable collection from Guava. I think in principle I don't have to. Couldn't I use an immutable multiset builder? And then build it at the end? So actually let's revisit. No, I'm looking for like symbols named builder. The ones that I used though in this, I guess I should search like this. Builder? Yes. Let's look back at this day when I use an immutable set builder here. What day is this? 8? So yesterday, I guess. I didn't really talk too much about this. I think this is something that most Kotlin developers probably would not do. I disagree with them, so I did it this way. It's not like something where I said, oh, this is exactly what a normal Kotlin developer would do, and then was just wrong. I suspect most wouldn't do this, and I did it on purpose. Why are we using an immutable set builder? If, like, one of the advantages of an immutable set is, like, you can pass it around to anybody, and you know it can't be mutated. If someone passes one to you, you know they can't mutate it later. You can throw it in a set, or have it be a key in a map, or all kinds of things, right? Immutable data is just much safer. But here, what benefits am I getting, right? I make an immutable set builder, and I build it, and then I just ask for its size. Like, what the heck is the point of that? The builder is in scope for way longer than the immutable built result. What's the point? I think the value that I get out of this is that it makes part 1 easier to read. In particular, whenever you have a function or a scope in general that has a mutable object in scope, it could be used in a variety of ways. You could, like, initialize it, set some stuff to it, you know, mutate it some, read it, mutate it some, read it, and you could be doing some very complicated, like, to understand what the program does, you might have to do some fairly complicated, like, mental math on tracking what's happened to it when and working out all this, you know, when the state transitions from A to B and so on. And sometimes, if you want to mutate something as you go, that's, you know, just what you have to do. But a large number of things that are mutated, collections, don't really need to be so complicated. You have kind of 2 phases of the program. Phase 1, you're populating the immutable collection, or populating the collection. Phase 2, you're reading it. And you don't interleave them. You never, like, populate, read, populate, read, populate, read. You have just a populate phase, then a read phase. But if this were a mutable set, you would have to read the program carefully to convince yourself that, yes, this really is just a phase 1, phase 2 thing. By using an immutable set.builder, I've made it impossible for myself to ever read the set as I'm building it. if you look at, visibles dot, it has add, it has build. It does not have any way to inspect the collection at all while you're building it. And that's what I've done. I've put shackles on myself to say, so that anyone who's reading this can tell at a glance that I don't read the set while I'm building it. Now, this is a small function. It's not that hard to, you could just, click here and see, oh, yeah. He calls add in a loop, and then he, calls size. If this were a mutable set, I wouldn't have the build. I would just be calling size. And you could say, oh, yeah, no problem. But this is just, a good habit to be in, I think. When possible, segregate your reads from your writes and make it impossible for anyone to be confused about whether you have done so. And make it as obvious as possible that you have done so. So anyway, this is why I was thinking here in part 1, I could just use a, what was I calling it? A mutable multiset. But I don't think I have to. In fact, wait a minute. What did I do with my other multiset? Did I make a hash multiset? Immutable multisets intersection. Here. I made a hash multiset. Why did I do this? Do I need this? I'm not sure. Yes. Well, yes. Here I actually am interleaving reading and writing, right? I probably if you had a builder, you could probably say remove something and that would be allowed. Maybe. I'm not sure. And obviously you could say add, but you couldn't say, how big is the set of things? And I want to interleave this stuff, right? I'm mutating counts in this function that I'm calling multiple times. So in this case, I think it was necessary to use an actual mutable multiset. But here I don't think it is. Well, I mean, of course, necessary is a strong word. I could have done something different, but it seemed right. The best kind of simple algorithm. Anyway, doesn't matter. Shut up. Just write a thing. So I think we can say... How do you say immutable multiset builder? Did I even do that ever? Here, do I have a... I don't think I ever actually used the builder. They should be around somewhere, right? You should be allowed to do that. Yeah, you can say immutable multiset builder. Great. And we will say this stores coordinates, of course. Make this a local, visit tail, positions visited by tail. But they're not positions, they're coordinates. This is a very long name, but I think it's worth being a little explicit here, even though it'll probably... There's sort of like a guideline in... Well, I don't even know how widely used this guideline is. It's probably like from Clean Code or something like that. But I learned it, I don't even know where either, I guess. That probably from Haskell, actually. When you're naming variables, you can choose to be generic. You can choose short names or you can choose long names, right? And the short ones generally imply more stuff. The long ones are more explicit. What should you choose? If you've read people online making fun of Java, which, fair enough, there are some things to make fun of. They choose very, very long names for symbols. Classes, variables, whatever. And, yeah, I mean, sometimes they're definitely too long in Java. But I don't think good Java uses super long members all the time. I'm very philosophical today. I haven't written any real code. Anyway, so the rule of thumb that I heard somewhere is A variable's length should roughly correlate with the size of the scope for which it is visible. In a one-line function, a variable named x is very reasonable, right? You know what x means just from looking at the parameter list or whatever. It's also the case that in more abstract code you have to be more general, right? A lot of Haskell functions take f and x, and all they know is f is a function that works on x. You can't really be any more explicit than that. But when you're working with something concrete, as you often are in Java or Kotlin, you do know specifically what a thing is for. And in business logic in general, right? Whatever language you're in business logic, you usually do have a specific purpose. And this is a business logic set that we're building. And I don't know how long this scope is going to be. I could get away with visited, but I think this is a pretty reasonable time to use a longer name. So I'm going to. And oh, I was saying, okay, we could map over all the parsed lines or the motions or whatever. But of course, we want to split each motion into move that way once, simulate it one step at a time. So we want a repeat function that lives on motion, maybe, that says as sequence of steps or something. But maybe that function is so simple that it can just be inlined. I don't know. We'll just put it here for now. Val, no, it's a fun, because it's not something we can initialize at constructor time. Is it? Of course it is. It can be a val. As sequence of steps. Don't need parameters, it's just a val. Is magnitude dot, can I say repeat or something? There was something called repeat, right? Oh, but this takes... I guess I can say... I can make a range from 0 until magnitude, right? 0 until magnitude dot map of direction, right? So let's test this in the REPL as well. Let's return 1 here. Presumably I'm supposed to build here, yeah. And I can say parse it's R10, or let's say 3, a smaller number, right? Dot as sequence of steps, right? It made a list, east, east, east. Perfect, that's what we wanted. So I think we want a var rope is just a rope of coordinate, hang on. Yeah, a rope takes 2 coordinates, right? There's my rope, yeah, a head and a tail. Well, let's let's say I shouldn't need the origin, right? Oh, there's a question. Does the origin count? They've marked the starting position does count. Yes. Okay. So let's actually say val origin equals coord of 0, 0. And let's add origin here, saying we visited the origin for sure. Oh, coordinate, thank you. And the rope is just a rope of origin, origin. We could maybe have this rope be part of part 1, because I assume the rope will be initialized the same way in part 1 and 2, but we don't know. And we don't really need to know. Let's actually initialize the rope first, so it's clearer why we should add. Do I still need this, by the way? I guess I do. Why, though? I'm saying add origin right here, isn't it? Okay, fine. So now I think we want to take the path.as sequence. Oh, as sequence might have been a bad name to choose because well, wait a minute. As sequence of the path is not correct, right? Path dot flat map of it dot as sequence of steps. Yeah, there we go. That's what I meant. Dot. I think I just want to like iterate over this, right? I kind of feel like I shouldn't be using a list here. Yeah. A sequence of steps, I guess. What does this return? It returns a list, huh? Okay. I feel like sequences are correct here, not... Actually, wait, what is the type of... Oops. It's a range or something, right? An int range. Yeah, so int range as sequence. So this way we don't have to materialize intermediate lists for no reason. And then we take this and we, like, probably just iterate over it, right? Now we just have a sequence of directions that the rope should move in. Great. Let's call it dir. And a dir is just a direction. So we can say we can compute the new head, I guess. Val new head is rope dot head plus dir, correct? Yes. Val, are we calling this a delta? Sure. Delta is rope dot, no, is new head minus rope dot tail, right? If yeah, we did write max magnitude. Delta dot max magnitude is greater than 1. You know what? Let's say val. Can I say const val? Is that allowed here? Doesn't look like it. Yeah, okay. Val rope length is 1. I suspect that this will become a parameter to the function, but I just don't want this magic number 1 showing up here for no reason. So if the delta is bigger than the rope length, we need to move the tail. I guess we're going to need to be computing the tail from this, right? So we should really say val new tail is if this, then no, because we want to only some. Okay, I'm going to do this separately, I think. I'm not sure. We'll see. So if the magnitude is greater than the rope length, then we can certainly compute the new tail should be rope.tail plus delta.clamp to rope length. Right? Ah, this is a coordinate. Right, we didn't make it possible to add coordinates yet. Should we? Probably. That makes sense. So you can add a scalar. You can add a direction. But you can add a coordinate as well. Add them as vectors, I guess. Maybe it shouldn't even be possible to add a direction. You should be able to convert a direction to a coordinate. Don't like that very much. It occurs to me, though, that these two are very similar. Should I just have minus be... Oh, no, I don't have a way to multiply. Wait a minute, why not? Did I not do that in day 8? I thought I did. I guess I was multiplying the components of coordinates. All right, whatever. So, right. Now we can say, get a new thing and clamp its magnitude. And we can say coordinates visited by tail dot put of new tail. Not put, but add. And then say, like we could here return new tail or something, right? Ah. It looks a little bit... So this is a pattern that we see all the time, I think. You compute something, you do some side effects based on it, and then you return it. Hopefully, somewhere in here, it'll suggest that I use... It doesn't, though. Oh, because I'm not using this return value. So I guess we could say val new tail equals. At this point, will you... Okay, so obviously the if doesn't have, but Okay, well, we'll leave that for a minute, and then I'll convert this to using letter also, or something like that. Else, which is new tail. Or it's just the old tail. Right? Now, are you gonna... No. Convert to run? That's not what I want. I don't want a width. That's so weird. This is the kind of thing I thought the IDE could... Can I, like, take that? No? So, but what I want this to be is this dot apply, or no, also? I don't really understand the difference between apply and also. I think one of them... So this makes coordinate... This puts the coordinate in scope. Does this not? It doesn't. I see. All right. It makes the coordinate the receiver, and this has no receiver. I don't want a receiver. So also... it. All right? So... And really, we should invert this if, I think. Is that... Hello? Invert if. Perfect. You like the simple version to come first. So that you can kind of just mentally process it and be done with it. And then you have, like, the complicated one last. And then we can just say, like, rope is rope of new head, new tail. And I know I could inline new tail here, but that seems nightmarish. I mean, okay, just for fun. Let's see what that would look like. Rope of new head and if. I mean, it's okay. There are times in my life I would write this, but I don't think today is one of those times. And I think here we can just say return coordinates visited by tail.build.size, yeah? Let's see what happens if we run this. Anything good, do you think? It's a number. Is it a plausible number? How big is our file? I was about to say, doesn't seem convincing. How can it have been to 8,700 places if it only moved 2,000 times? But of course, each of these moves is around, like, you know, 10. So really, it visited 20,000, it moved 20,000 times. It's very plausible that about half the time the rope went somewhere new. So I'll take it. Ah, don't click there. What the hell? Ah, I don't like that. I think it opened a... I think it opened an Explorer window or something horrible. Don't do that. So here's what I think my result is. Too high. Okay. Sure. Oh! What is the size of a multiset? Let's ask that question, because I think I was supposed to say element set.size. Wait, what is this? Oh gosh, I was looking at this and I was like, this looks like Kotlin, but it's not. It's very much looks like Java. I don't know why I thought it looked like Kotlin. Okay. Total number of all occurrences of all elements. Right. So the distinct is entry set.size, which we did before, but I forgot to do this time. So this counts duplicates where the rope stepped somewhere it's been before. So we should get a number that's smaller, but not by a lot. Oh, actually, that's quite a bit smaller. Return to day 9. Have I waited a minute? I'm not 100% sure, but it's probably. That's the right answer. Okay. Little slip up there, but I had the right idea. So let's do some committing. I think all of this, even though it includes changes to the coordinates file, like I guess I could commit this separately. Sure, why not? Allow adding and subtracting coordinates. Why is it? Oh yeah, that is the diff. You're right. The whole file's green. Day 9, part 1. So now we're ready for two different things that part 2 could possibly be, right? If they say, oh, the rope's a different size, I'll be ready. If they say, oh, you're supposed to count even the places it visited multiple times, or if they won't say that, but if they say, oh, what spaces did it visit 5 or more times, I'll be ready for that too. I think more likely they're just going to say the rope is bigger, and I think we're in great shape for that. So let's see what part 2 actually is. A rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping toward you as you fall through the air. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots... Ooh. Okay, this I did not predict. You must simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to a series of motions. Each knot further down follows the knot in front of it using the same rules as before. I see. So it's a longer rope, but it's not just like a rope with slack in it. Exactly. It's a sequence of connected ropes. Cute. Using a series of motions, knots marked, head, blah, blah, blah. Uh-huh. Now is this... Knots marked 1 through 9. When the head moved up to here, 1 moved diagonally to follow it. 2 moved diagonally to follow 1. 3 moved diagonally to follow 2. 4 moved diagonally to follow 3. Okay, I see. Yes, this all makes sense. More types of motion are possible. Yeah. What do you mean when you say more types of motion are possible? Oh, you're just pointing out that... Well, is this possible? Is it possible for a single knot, to move a distance of more than 1 in a single step? Obviously, it's possible to move diagonally. To have something that we're thinking of as a head, because it's like the tail of a previous rope, could move diagonally. But could it ever move by more than 1? I don't think it could. Yeah. I mean, I don't know. Just looking at this, I'm not like 100% convinced, but... Yeah, so the tail, I mean, it was following a series of diagonal motions and stuff. But, I don't think it ever had to move by more than 1. So our idea of clamping, like, makes sense, right? Well, you got me with part 2, Eric. Good job. I didn't anticipate this. I said, okay, surely the rope will be longer. But I didn't think about how you would make the rope longer. Okay. Well, here we are, back in day 9. I didn't really extract anything out of part 1, even if it seemed reusable, because I sort of predicted that all of part 1 itself would be reusable. I would just like pass 1 and pass 5. And I think that is what I will do. I just need to change this to be parametric in the number of knots in the rope, right? Or number of tails or something like that. Which I guess we'll call the rope length. So, I mean, I don't think this is so bad. We just, instead of tracking the rope, what does a rope have? Nothing. It's just a head and a tail. Which it turns out is like not that useful for us anymore. We really just want to track some number of heads and some number of tails, right? Or, well, some number of... If we have a rope of size 1, we want to track... Sorry, a rope of size n. We want to track n plus 1 coordinates. The 0th one is the head, and the nth one is the n plus 1th one is the tail, and the ones in between are like, you know, the heads and tails of intermediate they're the knots in between, right? So I think, like, where do I use rope? Only here, right? Yes. So soon we will delete rope. And rope length, I guess, also will not really be something we need to parameterize over, but it's still a useful constant. So let's see. Let's change this function. Let's rename this function to be, simulate rope, and it takes a parameter 1. Add first parameter, it's an int, but of course it's not called path1, it's number of knots? I mean, really it's number of knots, like, maybe I'm going to pass 2 or something, but let's call this num knots, not to be confused with num nuts, an insult from the 80s or 90s. So now we're using rope length. We can extract this to a... It is constant, though. What do you mean I can't... Oh. Can I... Alright, whatever. There you go. But let's... I think Kotlin has the same, like, conventions about consts being... caps? I'm not sure. So there's the origin is 0, 0. That's fine. Now I actually want to visit the origin first here. And it turns out we don't need a multiset anymore. We know, but I mean, I don't know. I guess we could leave it in. It's fine. We'll know more about the rope than anyone else who solved this problem. No, probably not. I don't understand the rope as deeply as the other programmers, but some of them anyway. But hopefully my program will have tracked information that completely useless information that no one else tracked. I'll be a data hoarder. Okay, and now I think what we need is basically, we don't want a rope anymore. We want do I want a mutable list of coordinates? Or do I want a var which contains an immutable list of coordinates but can be updated to point to new immutable lists? Like, this seems like a job for reductions in a way, right? Whatever that's called in Kotlin. Where you have some value which... it's like a scan, right? This is a scanl or something. We have... is it crazy to actually not have a list of size n+1, but instead to have a head and then a list of tails or knots that's of size n? That seems kind of nicer, actually. The head is special because we update it with a direction. But all of the others, we update by telling them, here's where the head you're attached to, or the other knot you're attached to, has gone to. A position, or a coordinate, rather, right? So, and that makes it much easier to do like a scan. So I think I like doing that, actually. Val head is coordinate, actually it's just the origin. But head is a var that starts at origin. We're going to be updating head. And then we can say we have probably a var immutable list. Knots is 0 until num knots map origin, right? And then we have this whole thing. Now we can't so easily distinguish the tail anymore to decide whether we should modify the places it visited. Okay, now's the time we give up on the immutable multiset and we just make an immutable set. Oops. Oh yeah, import it please. Sorry, I interrupted you when you were trying to import. Okay. Oh, this should... really? You can't figure out... I thought it might autocomplete. Oh, there's something called rope length in scope. I just assume the editor is impossibly smart, and every time it doesn't do something, I'm like, really? That doesn't seem that hard. My expectations have gone up a lot since 1995. Well, I wasn't programming in 95, but like 2001, I guess. Which was about when I discovered Eclipse. No, I discovered Eclipse in 2003, I think. Anyway, it was amazing at the time. For a while in my professional career, I kept trying to use Eclipse to write Java, but like, IntelliJ is so much better than Eclipse is now, and Eclipse now is so much worse than Eclipse was then. Alas. Right, so I was saying I want to look up in Kotlin, like Kotlin scanl. Is someone going to tell me, like, here's the version of... Oh, I spelled scanl wrong. No wonder I'm not. Scanl. Okay, it's called scan. Great. Let me just show you the docs for it. These are for arrays, but I assume if I keep going, I'll get to lists and sequences and stuff. Uint array. Oh, we have uints. Is there no... iterable, huh? And it produces a list. Why can't I have a sequence? Maybe there is one for sequences? Yeah, you can scan and get a sequence. Okay, cool. So, although I actually have a list, and I want a list back, so I guess I'm using lists scan. So I guess what I do is I say new head is head. Ah, yes, correct. For each direction, I'm getting a new head. That is true. But then all this other stuff is going to have to be different. And I'm going to say knots equals knots dot scan of new head and a lambda? Call it H. This is like, well, I mean, maybe I just use it. Like, there's not much to do here, right? No, I still have to do this if, right? Yeah, so let's just say H to delta is H, no, new head, I guess this should be T actually. Okay, you're just telling, wait. Yeah, you're telling me I haven't finished writing the lambda. That's fine. If delta is less than rope length, then we just return tail. Otherwise, we return tail plus delta dot clam magnitudes to rope length, right? Now, why are you still mad? Oh, it should take two. Right. HT. Okay, got it. So this all type checks. It's not correct, but because I haven't yet updated coordinates visited by tail. But I think that just goes here, right? Coordinates visited by tail dot add of knots. Is there a way to get like the last or something here? Knots dot last? Sure. So I think that makes sense. And here, how many do we have? We have the head and 10 tails or 9 tails? Yeah, 1 through 9. So actually it's 9. Let's run this and see what happens. Oh, I didn't... This shouldn't just be head, it should be... I should just update the existing head. There we go. I should have checked the warnings. It was trying to save me. Oh, do I want to use plus equals? Sure. Why not? Ooh, what order does scan take its arguments in? They're both type T, right? No, T and R. So R is the initial, and T is the list element. That's the second one. Yes, this is what I wanted. Still 1, huh? Okay, I was hoping I would be done and wouldn't have to take a break, but I do actually have to take a break. BRB. Okay, so we got 1. The first question is, well, this should say 2, I guess. Not important, of course. Are we using num knots? We are, right? So head plus equals the direction we're going. And then we scan the list, starting with head as the delta, right? And then we say, what does scan return? A list containing successive accumulation values by applying this from left to right to each element. And current accumulator value starting with initial. Yeah, that seems right. Take the head and subtract the tail. And we return either t or this other t plus delta dot clamp to 1. Really shouldn't call it rope length maybe, but sure. I'm updating the head. I'm updating the knots. All right, let's throw a debugger in there, I guess. Let's maybe only debug it for part 2. Well, no, wait. Even part 1 is wrong, right? So actually, it's very useful to... All right, stop. Start over again. Since even part 1 is wrong, and part 1 should be way easier to debug. So, head currently is origin, and we're moving east because okay, we can inspect dir, but we don't really need to. It just says go east. And we can't inspect what the original thing was, but we can just find it in our text file. We're going east for one time. Fine. So head is now x1, y0. That's correct. Knots.scan. So this is where the excitement happens. We're here. And tail is 0, 0. Head is 1, 0. So the delta is less than or equal to the rope length, so we don't move the tail. That's correct. And what is now knots? Why is it a list of size 2? Ah. It includes the thing you started the scan with, just like scanl does, and I didn't think about it. Okay, so let's open the REPL again real quick to test what I believe is going on. Let's say we wanted to compute the sum of the first 10 integers or something, or the partial sums of the first 10 integers. We would say, you know, 1 until 1 to 10? 1 to 10, let's say. Dot scan 0 lambda sum x to, I know I could just use int plus, but I guess I should, right? Int plus. Okay, fine, I'll write it myself. xy to x plus y. Is that all I was supposed to do? No. Receiver type mismatch. Oh, I need to make it a sequence. As sequence doesn't, oh, not as sequence. Yeah, very funny. What am I missing here? Is it only on lists? I thought it was on sequences, but okay. To list. All right, this looks good. What the hell? Oh, one. What are you supposed to call in a range? Is it not to list? Oh, not 1, 2. God. Got me. It gets me every time. I'm used to just reading ... as 2. 1 to 10. And I write a 2. Ugh. Okay, and so now as sequence should exist. And we can scan it. Oh, but sequences are not immediately realized, so fine, give me a list. And indeed, we get the 0. So the initial thing was added to the front of the list. So that's the problem, right? Is that we made the rope longer every time we pulled on it, and so the tail never moved. So we can just say drop. Is there a way to, like, maybe I can just look this up. Kotlin scan not include first element, something better than using sublist. No. All right, there doesn't seem to be anything especially efficient here, so we'll just use sublist. I thought, oh, it's a sequence. This is a sequence. No. Knots is a list, isn't it? Does sublist not have... It has from too? I thought, like string, you could just specify the from index. Am I crazy? I must be. Java doc... Well, why don't I just look in the IDE, actually? So this is Java... No, this is collection.kt. Oh, you... Of course, we're using a Kotlin list. Okay, I mean, fine. But if I used a Java util list, it would be there, right? Like if right here I said array list from Java of whatever dot of int. No, it doesn't. Okay. It always says from and to. You got me. From 1 to... num knots plus 1, I guess? Is there a better way to say, like, drop? Like, I mean, obviously drop exists. I guess drop exists in iterable, and that's really what I wanted anyway. Drop 1. Not efficient to use a scan on a list, and then, I mean, like, really, I guess what we should do is say as sequence here, scan the sequence, drop 1 from it, and then to list it, and then we don't materialize the intermediate list for no reason. So if I run this now, is that all I was missing? Yes, 5874, I believe, is the answer we had before. So let's just double check that before we enter it, of course. 5874. So this correctly models 1 knot. And we get a smaller number, which seems correct, for a larger rope. That's the right answer. Great. All right. Oops. Sorry, I was supposed to alt-tab before I switch scenes. That's not too bad, right? You know, we could maybe move this up here. I still feel like there's got to be a better way to do this. I want a list of n of the same thing, right? But whatever. 0 until is fine, I guess. So we take the sequence, we flat map it as a sequence of steps. We move the head. The knots we scan We drop one and we listify it. That seems fine. Yeah, I'm reasonably happy with this. We should get rid of rope, of course. Turned out not to use it. Oh, lured, there's a typo. It's not a word. Yeah, if you could read at all, you would know nobody ever types words into this part of a regex string. Immutable set, use all this stuff. Yeah, seems right. Let's commit it. Day 9, part 2. And I guess I should push it before I forget. Push. All right. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.